In example 1 for this learning objective, we're asked to write an equation for each sentence. This is a little bit different than the last few examples, example 1 and 2 from the last learning objective, because there we were asked to write an expression. So an expression does not have an equal sign. Here, we need to write an actual equation. We're going to take the same process though that we used for the others. If we look at the first one, it says the 1,840 rock concert tickets sold was double the amount of jazz concert tickets sold. Okay, well, we know one thing. We know that there was 1,840 or 1840 rock concert tickets sold, and that was double, or was equal to, or is equal to double the amount of jazz tickets sold. So double would mean 2 times, and then we need to introduce a variable here. We don't know how many jazz concert tickets were sold, so let's let J equal the number of jazz tickets. The great thing about this changing this sentence into a mathematical expression is this is, or an equation, excuse me, this is now something we could solve for J. So if you had to, you would divide by 2 on each side, and you would get J to be a value. But that is not part of this problem. We're just asked to write an equation for each sentence. So 1840 is equal to 2J is what we have written down for this one. Kaylee goes bowling on Saturday afternoons in example 2, and she bowls 3 games and pays for shoe rental. Define a variable and write an expression, to represent the total cost Kaylee pays. So in this case, we're asked specifically to write an expression. So let's do that. This original sentence here, she goes bowling, it's kind of helpful, and it's on Saturday, but that's not really important to the problem. What's more important is that she bowls 3 games and pays for shoe rental. And if you haven't bowled at all, this might be tough, but I've done a little bit of bowling in my day, and usually when you pay for a shoe rental per day, it's just 1. You don't pay for the shoe rental for each game. So the shoe rental is going to be the thing. We don't know it, so it has to be a variable. But it's going to be something that'll be constant, that won't be changing once we know what that is. But since we don't know what it is, we'll introduce a variable here, and we'll go with S. So we'll say let S equal shoe rental, and that's going to be in dollars. And then the other thing we don't know is we don't know the cost of the game. We know that she bowled 3 of them, but we don't know the cost of the game. So let's let G equal cost of each game. Oops, that shouldn't be an 8, huh? That should be just a $sign. And now we can write our mathematical expression. 3 games, so that would be 3 times the cost of each game, which is G, and then we need to add the cost of the shoe rental. So that would be S. If you can make your S's look pretty curvy like that and not look like a 5, S is a good variable to use. If your S's kind of look like 5s, then I would choose something else, maybe R, reminding you that you're paying for the shoe rental. In number 3, the cost of renting a bike is $10 to take the bike out, and $4 every hour it spends in our possession. So we'll go through the same type of thinking that we did before. And let's see, we've got the cost of renting a bike is $10 just to take the bike out, okay. And so that seems like it's a one-time fee, you pay it and that's it. And then $4 for every hour, or for each hour that you will have the bike. So to me, the cost of renting the bike is constant, and we know what it is. So we don't need to introduce a variable here. But we don't know how many hours we're spending. So let's see here. Let's let C equal the total cost. We don't know that either. And then for our other variable, let's go with, we'll just do h again. And that'll be time in hours that the bike is in our possession. So the total cost will be equal to, okay, 4h. So it's $4, and that's gonna, this total cost here is gonna be in dollars. We want to write down our unit. 4 times however many hours that you have the bike out. So if you have the bike out after 1 hour, you just get charged $4. If you have it 2 hours, it's another $4 or 8. In other words, it's 4 times 2. So you can tell here that we're multiplying the 4 and the h, so that's appropriate. And then for every single, for the day, you just need to add that 10 there. You don't need to multiply by anything. That's just a fixed cost. So we have the total cost being 4 times the hours plus $10, which is the cost of just renting the bike. In example 4, we've got admission to the fair is $7 per person, and each ride ticket costs $2. We need to write an algebraic expression this time, so no equal sign, that will represent how much it will cost David to go to the fair if we do not know how many rides he will go on. Okay, and that's not given in our problem here. Admission is a one-time thing, so at least for that night. We're just talking about that night, and you just pay it once. And then each ride, or every ride, costs $2. Or another way to say that is it's $2 per ride. So we're talking about a rate here, and we're going to need to multiply that by however many rides that David goes on. So the variable here, let's make this maybe just an r. So r will be the number of rides that David goes on. So we know we have to multiply that by 2, that's the cost per ride, and then we need to add $7. I hope you're seeing how some of these situations are related and how you can work through these problems. Word problems are sometimes students really shy away from them, but they're really not that bad once you learn and once you practice in writing these into algebraic or mathematical expressions and equations. And if you can do that, then the whole world of algebra is open to you, and you've got a lot of different tools you can use to help you solve these problems. In number 5, Hope received 90 votes for student council president, which is 50 less than twice the amount that Tom received. Okay, so we know how much Hope received, but we don't know the amount that Tom received. So let's let T equal the votes for Tom. Okay. We do know in reading this sentence, though, that 90 is equal to, which were, or is equal to, 50 less than twice the amount that Tom received. So we can write our twice the amount that Tom received, or 2t, and then less 50, or 50 less, is going to be minus 50. Be very careful with these ones. These ones are often written 50 minus 2t, but that would not be correct. So you need to actually look at the last part of the sentence and then take away 50 from twice the amount that Tom received. So if you need to think about it like that, please do. In number 6, the 347 students who listed soccer as their favorite sport were 13 less than 3 times the number of students who listed basketball as their favorite sport. Boy, that's a little bit wordy. So we know that 347 students listed soccer as their favorite sport. And then, let's see, that's 13 less than 3 times the number of students who listed basketball as their favorite sport. So in reading that a second time, it seems to me that the one thing that we don't know that's going to be our variable is going to be the number of students who listed basketball as their favorite sport. So let's do just B here. So we're going to let B equal the number of students listing basketball. There were 347 students who listed soccer as their favorite sport. And that was 13 less than 3 times the number of students who listed basketball as their favorite sport. So if we look at 3 times the number of students who listed basketball as their favorite sport, that's going to be 3b. And then 13 less, or less 13, is minus 13. These two problems are really kind of the same thing. You got to look at the end of the sentence and write that down first, and then take away whatever that value is. Here it was 50, and then here it was 13. Just a couple more in this example. I believe we've got 7 and 8. Number 7 says a pizza delivery driver earns $7 per hour. That word's going to be important. Plus $1.50 for each delivery made, and that's going to be important too. We're going to write an algebraic expression that represents this situation. This situation, it seems like it might be only per hour or just 1 hour, but what I'm going to do here is I'm going to introduce 2 variables because we don't know how many hours this pizza delivery driver has been out on the road, and we also don't know how many deliveries that person has made. So let's let h equal the number of hours, or time in hours, and then let's let d equal the number of deliveries. So if we have 7h, 7 times the number of hours will give us the amount of money this person makes from the hourly wage, and plus, or adding 150 or 1.5 times d, which is the number of deliveries. And we're asked to write an algebraic expression, so we're good to go here. We don't need an equal sign. You could, if it said to write an equation, you might have C or M, the amount of money that this person made, is equal to, and then you could set that equal to this expression. Alright, the last one. Congratulations if you've stuck through this all the way to the end. Isaiah, who has all 13 girls' phone numbers that are in his homeroom, has 3 more than half the number of girls' phone numbers that Jacob has. So we know how many Isaiah has, 13. We don't know how many Jacob has, though. So let's let J equal the number of phone numbers. That sounds kind of weird. Number of phone numbers that Jacob has. Alright, we'll go with that. Jacob has. Okay. So Isaiah has 13 girls' phone numbers. And then now we're talking about Jacob, and we're relating these two. Got a comma and has here. 3 more than half the number of girls' phone numbers that Jacob has. So if we took Jacob's and split it in half, or divided by 2, that would be this part. And then 3 more would be plus 3. Be very careful, this plus 3 needs to be off to the side. Definitely not up here by the J. That wouldn't quite be right.